In this video, we're going to continue our discussion with applications of the normal distribution. So, determining the value of a normal random variable that corresponds to a certain proportion, probability, or percentile is useful. So we know the z-score formula is the data value minus the mean divided by the standard deviation. So solving for x, I can multiply both sides by theta. That would give me z theta is equal to data value minus the mean. Add the mean to both sides. And I have the x value by itself, so it would be the mean plus z times theta, or z times the standard deviation. Now, we will not use the z table for these problems. I will show you how to put all of these into the calculator. So let's take a look at a couple of examples. So a survey among freshmen at a certain university revealed that the number of hours spent studying the week before final exams was normally distributed with a mean of 25 hours and a standard deviation of 7 hours. Determine the 32nd percentile of the number of students studying. So for us, 32nd percentile, well, that talks about 32% or less. Okay? So again, we want it to be x is less than 3200. Now, notice what it's not asking for. It's not asking for a probability or a proportion. So the graphing calculator technique we will use is the inverse norm. Now, the inverse norm talks about the area that is to the left. Well, 32%, that's the same thing as 32 hundredths, so it'll be 32 hundredths, comma, what the mean is going to be. Well, the mean in this case is 25, comma, what the standard deviation is going to be, that is 7. So that's a setup that I would have on the paper. Now, let's try to figure out how to put this into the calculator. Okay, so this is how to find inverse norm. Go to second and vars. Now, number 3 is what I'm looking for. Okay? So now it's asking for the particular area that's to the left. Write it as a decimal, 32 hundredths. The mean in our particular case, that is going to be 25, and the standard deviation is 7. Now, for the tail part, if this is an available option on your calculator, I will always put that to the left, so I will never move that. Highlight, paste, and hit enter. Okay. And then I'll write it to 1 decimal place on the paper. That's 21 7/10. Now, I will round this to the nearest hour, so this is approximately 22 hours. Don't forget your unit of measurement. Okay, part B. Between what two values are the middle 80% of the hours spent studying? Again, it's not asking for a probability or a proportion for this, so I know I'm going to be using inverse norm for this. Now, let's draw a picture for this. So I've drawn the bell curve with the 80%. Now, because it's symmetric, we know both of the ends are going to be 10%. So the middle 80% would be here for the lower end, and then the upper end, that is going to end up being, we'll put it here, here. So what percentage is to the left of the lower one? Well, that is going to be what? 10%, and I'll rewrite that as 0.10. The upper is the 80% plus the 10%. That is going to be 90%, which of course I can write as a decimal as 9/10 or 90 hundredths. So there's 2 inverse norms, one for the lower part, one for the upper part. So inverse norm, we'll do the lower part first, that's 1/10, comma, the mean, which is 25, comma, that is 7. And then the other one for the upper, that's going to be inverse norm. That's going to be 9/10, comma, the mean, comma, the standard deviation. So we'll put both of these into the calculator now. Okay, so how do we put this in the calculator? Second, vars, go down to inverse norm, which is number 3. So we'll do the lower one first. So we'll change this to 1/10, hit enter. 25 stays the same, 7 stays the same. The tail, I'm still going to do the left, so hit the down arrow, highlight, paste, hit enter. And that's going to be 16.0. Now, let's do the upper one then. So again, second vars, again, inverse norm number 3. Here, the 1/10 I'll change to a 9/10, hit enter. 25 and 7 still stay the same. Highlight, paste, hit enter. And actually rounding to 1 decimal place, that looks to be 34.0. So we'll put this on our paper now. Now, so we'll write. So we're looking at approximately between 16 hours and 34 hours. Right? Again, assuming we're rounding to the nearest hour here. Okay, let's take a look at the next example then. So according to the College Board, the mean quantitative SAT score for college-bound high school seniors in 2012 is 530. SAT scores are approximately normally distributed with a popular standard deviation of 100. What is the SAT score at the 96th percentile? Now again, notice what we have. It's normally distributed, right? Similar to the last problem that we dealt with. Again, it's not asking for a proportion and it's not asking for a probability. So this is going to be an inverse norm. Again, we're back to percentiles. That's going to end up being then 0.96. The mean in this particular case of things, that is 530, and the standard deviation is 100. Okay? To the nearest 10th, it's going to give me this. But again, we'll round to the nearest whole number, so it's going to be approximately a 705 SAT score, which I'll write now. Okay, last thing I want to have a quick conversation about is what's called this Z sub alpha. And this is a z-score such that the area under the standard normal curve to the right. Now, if I want to figure out what z sub alpha of 0.25 is going to be, now remember, it's to the right. When we do inverse norm, which is what I'm going to use, it's going to be to the left. So it would be what? 1 minus 25 hundredths, that's 0.75. So when I do this, it will be inverse norm of 75 hundredths. Now again, it doesn't give you a mean or a standard deviation, so the mean is 0, and the standard deviation is 1 when it's not given. Right? We get okay, final note then. When x is in between a and b, remember, it does not matter whether a is included, b is included, neither one of them are included, or they're both included because it's continuous. Unlike a discrete random variable where less than or equal to are totally different things, or greater than or equal to are two totally different things.